This is the wireless power transfer team, and we got here today Tommy, Blake, Zach, Luke, Abby, and me, Wyatt. We got two people missing. They're Frank and Brandon, but they couldn't make it. So yeah, here's the project. We have two antennas here that we're going to be transmitting and receiving power for lunar applications or like drone applications that you want something to fly longer or operate longer without having to go to a charging station or anything like that. So yeah, we can see we got two antennas. They just transmit and receive power, and let's look at the circuitry behind them. Here we have is the whole system, all the electronics we're going to use. Right here on the right for me, you can see the signal generator. This is what is used to generate a signal to transmit the power. And on this side here is our rectifier, which takes that power and turns it back into a usable form for charging batteries and all that. And here we can see on the spectrum analyzer we have some power output from the signal source. And yeah, let's dive into the components. So right here we have a little Arduino microcontroller. All its job is to, when the thing turns on, is program some registers inside of the signal generator board right here. It's a PLL, which is basically a frequency synthesizer. It takes a reference frequency from like a crystal or something and then turns it into whatever particular frequency we want. Like I said earlier, we're operating at 5.8 gigahertz. And from there, we would normally feed it into this amplifier that takes the signal and increases the power level so that we can transmit sufficient power. You can think of this as like the thing that goes to your loudspeakers in your car from like your radio. And yeah, we can see that everything's producing a signal. We don't have it hooked up to the power amplifier because it's broken currently, but it's pretty cool looking. If you want to take a cool look in there. It looks pretty cool. We accidentally burnt it up, so we got a new one coming in later. And here we have the two rectifying boards. We have our antenna input right here, so we hook this up to our antenna, and then the signal travels down it and rectifies it in a voltage doubler circuit. And we can see the cool geometries on the board here is stub tuners and stuff to make sure that the impedance is properly matched to the load. And it'll make things more efficient and whatnot, and it looks really cool. So this is one we etched in-house. We did a photolithography, so we put a mask on it, exposed it to light, and then developed it, and then etched it. And then this one we bought offline. We can see that they're mirrored because I accidentally messed up the exposing process, but still worked just as fine. So yeah, the efficiency we achieved on our boards was about 10% from the antenna, and then the overall transmitting efficiency we got was about 4%, which is pretty low, but in the grand scheme of things, it's kind of what we expected because we're limited by the sort of practical limitations of how the world works. As you double your distance between the antennas, the power you received is cut in a quarter. So it's a pretty tough problem to solve, but we got somewhere.